Today's lesson is about the angle measures of triangles. Okay, so first we're going to do a quick review of the classification from the previous lesson. You'll notice the vocab words on the left are in blue. Those are classifying triangles by sides. The ones on the right in red classify the triangles by angles. Okay, so if you look at the first example, based on the sides, there's three different marks. Okay, that means that the sides are three different lengths. The kind of triangle that has three different length sides is a scalene triangle. If you look at the angles, the three angles are all different. Notice they're all less than 90 degrees. That makes it acute. Okay. The second triangle, all the sides are marked the same, so it's equilateral. Also, all the angles are the same, so it's equiangular. Equilateral and equiangular always go together. Okay, check out the next examples. Letter C. For this one, again, all the sides are different, 6, 8, and 10, so that makes it scalene. As far as the angles go, there's a right angle marked, that makes it a right triangle. Okay, and the next one, two sides are 12, one is 26, because two sides are the same, that's isosceles. One of the angles is 140 degrees, that makes it bigger than 90, so it's an obtuse triangle. Okay. Next section is a review of the segments on the triangle. First of all, there's an altitude. If you remember, an altitude starts at a vertex, and then it is perpendicular to the opposite side. So go ahead and try to draw a segment that meets the other side at a right angle. Okay, a median also starts at a vertex, but rather than being perpendicular to the opposite side, it goes straight to a midpoint. Okay, so try to locate the midpoint on the opposite side, and then draw the segment connecting the vertex to that midpoint. Okay. An angle bisector is a segment that starts at a vertex and then cuts an angle into two congruent angles. So if I start at this vertex, then I should try to draw a segment that cuts the angle so that this angle is the same as this one. Okay. And then the very last type of segment through a triangle is the perpendicular bisector. The two words tell you what it means. Perpendicular means it goes at a right angle. Bisector means it bisects a side. So again, I need to locate the midpoint of this side, because I know I'm bisecting that side, and then I've got to draw a segment that goes through that midpoint at a right angle. Okay, and I can label it with a box to show that it's a 90-degree angle. Remember, a perpendicular bisector is the only kind of segment that doesn't necessarily go through a vertex of the triangle. Okay, on to the new stuff. Note the sentence in green at the top. The measures of the three angles in a triangle will always add up to 180 degrees. Okay, that's very important. You're going to need to know it for the entire year. So all three angles of a triangle have to add up to 180. So like for this first example, I'm trying to find the unknown angle, call it x. I know that the three angles add up to 180, so that's how I write my equation. X plus 75 plus 40 adds up to 180. Okay? And then I just need to solve my equation using the algebra you learned last year. 75 plus 40, that's 115. Okay, and then I can subtract that 115 from both sides, and I end up with x equals 65. Okay, so the last angle of that triangle is 65 degrees. Okay, check out example 2. This one's a little different. None of the angles are labeled. However, they do have that same arc. If the arc is the same in every angle, that means they're all the same measure. Okay, so if the one in the upper left is x, I can count all the other ones as x as well, because they all have the same arc. Okay, so when I set up my equation, I'm adding up the three angles, x plus x plus x equals 180. Okay, and then I just need to solve. These are all like terms. Think about it as 1x plus 1x plus 1x. All together would be 3x. Okay, and then if I'm trying to get x by itself, divide both sides by 3. X is 60. Okay, which shouldn't be surprising, because if all the angles are the same, it's an equilateral triangle. Equilateral triangles always have all three angles be 60 degrees. Okay, number 3. This one's kind of like number 2 in that two of the angles aren't labeled. However, they have the same arc. So again, go ahead and call them both x. Okay, so when I write my equation, x plus 40 equals 180. Okay, and then I've got to simplify. Like terms, 1x plus 1x would be 2x. Okay? And then I need to subtract 40 from both sides. So then I have 2x equals 140. Last step, divide by 2, x equals 70. That means both of the angles in that triangle that aren't labeled have to be 70 degrees. Okay, we got a couple more like this. Let's see, I'm trying to find two angles on this triangle. They're not necessarily the same. However, these two angles together, they make a 180-degree angle because they're a linear pair. Okay, so I can figure out this one simply by subtracting 180 minus 150, 30 degrees. Okay, so this unknown angle has to be 30 degrees. And then once I have that much, I can set up my equation. To find this, say this one's x, 80 plus 30 plus x equals 180. Okay, so now I'm solving for the last unknown angle on the triangle. 80 plus 30 is 110. Subtract 110 from both sides, and I get x equals 70 degrees. Okay, so the unknown angles on this triangle were 70 degrees and 30 degrees. Okay, and then the last example of this type is actually a right triangle. Whenever you see that box in the corner, that's a big clue. The box means it's a right angle, which means it's 90 degrees. Okay, and then I can use that information to set up my equation. I'm adding up the three angles of the triangle. 90 plus 47 plus the third one, which is labeled as 5x plus 3, all together has to be 180. Like terms are the numbers. 90 plus 47 plus 3. You could definitely use a calculator for that. You should get 140. Okay, and then to solve, I would subtract the 140 from both sides. So you get 5x equals 40. Divide by 5. So x equals 8. But I'm not quite done because I have to plug that back in to this expression here. Figure out what that angle is. It's 5 times 8 plus 3. Which is 40 plus 3, 43 degrees for the unknown angle. The last definitions for today are interior and exterior angles. Okay, all you have to do is think of what the words mean. Interior refers to inside. Okay, so they're the angles inside the triangle. 6, 3, 12. Exterior angles are angles that are outside the triangle. Okay, so those are the angles that include one side of the triangle and one extended side. Those angles are like 5 and 7. On this angle, they're 4 and 2. And then 11 and 9. Note that 8, 1, and 10 are neither interior or exterior because they contain two extended sides of the triangle. Each exterior angle has two remote interior angles. They're the two angles in the triangle that are not touching the exterior angles. Okay, so first of all, we've got to find the remote interior angles for each exterior angle. So take a look at exterior angle 5, which was this one. The remote interior angles are the two interior angles that are not touching that exterior angle. So not 6, however, both 3 and 12. If you look at the exterior angle 2, which is over here, the interior angles that are not touching that one would be 6 and 12. Okay. The exterior angles that are not touching 11 would have to be 3 and 6 because 12 is adjacent to 11. Okay. So that's the difference between interior and exterior angles.